Okay, here we're going to talk about saturated mixtures. Saturated being, the equilibrium when water comes to a boil, say, or any substance, pure substance, comes to a boil. It's a nice little pan. Put a pan on the stove. Put a little water down in the bottom of it. Let's make it 1 pound of water. Then I'm going to put this little invention, like a little Jiffy Pop bag that keeps the air from coming in but doesn't change the pressure. So the pressure in the atmosphere is 14.7 psi. That's 1 atmosphere. That's standard atmospheric pressure. And we have this water down in the pan, and it's liquid so far. So what we're going to do is we're going to heat that water and watch its volume change. Got a little flame under the water. We're going to watch this volume change. We're going to plot over here. Going to plot temperature on the y-axis and volume on the x-axis. So we'll watch the volume increase as we add the heat. If we start down here at room temperature, let's say about 70 degrees Fahrenheit, and we have a very small volume. So we take that volume, and it starts as we add heat to it, the temperature rises, and the volume goes up ever so slightly until we reach the boiling point, which at 1 atmosphere is 212 degrees, 212 Fahrenheit. And then what happens? At that point, little bubbles start to form. Little bubbles will form in the water, and it'll start boiling. And we all know when water boils in the pot that the temperature doesn't rise. It just sits there and boils and boils and boils, and the volume increases. But it's increasing while the temperature stays constant at 212. And we call 212 the saturation temperature for the pressure of 14.7 psi. So what's happening is this little Jiffy Pop bag is coming out of the pot because it boils. So we're containing the water so we don't have any air in it. So it's all pure water, and this bag expands almost to fill the whole room. As the water becomes completely gas, it becomes total gas and fills that bag, but the temperature stays the same. Now it's only when the water becomes completely vapor that the temperature will rise again, and the volume will go up again. The volume's been going up, but it'll go up more, and the temperature will rise at that point, only once it's a total gas. Now there's a word for this. It's called saturation, and what we have in between here, where we have a liquid just about to boil, and now we have a vapor that's just finished boiling, we call this region in here the saturated region. And we have in here a saturated mixture in between the liquid here, which we'll call down here, this will be VF, the saturated liquid volume, and over here VG be the saturated vapor volume. In between the saturated liquid and the saturated vapor, we have the mixture. To the left of here, to the left of the saturated liquid, this region in here we'll call the compressed or the subcooled liquid region, compressed liquid. And to the right, after we've boiled it completely and we start to heat it up some more, we call that a superheated vapor. Superheated vapor in this region. Now, to quantify how much of this is liquid and how much of it is gas, we use a concept called the quality. Quality. The quality X is equal to the mass of the liquid in the mixture divided by the mass of the mixture. Or let's say that's the mass fraction of, the mass of the vapor. Oh, that's so important. The mass of the vapor over the mass of the mixture. That's why they call it quality. Call it quality because you can do a lot more with a vapor, with steam vapor, than you can do with liquid. And so the more vapor in the mixture, the higher the quality of the mixture. So over here at saturated vapor, we call it right here, just when it's finished boiling, it's a saturated vapor. That has 100% quality. Over here where it's just about to boil and it's still a liquid, that has 0% quality. So that's kind of an introduction to saturation, and we'll get into that a little more in the next video.